So today we are going to start the capacitance thing. So up to last class we have discussed the problems in inductance. So in transmission line, so we have to find something that is R, L, C. We have to find out. So we know how to find the resistance R. Then we have completed how to find the inductance L. So we know the formula for inductance L. So L will be equal to 2 into 10 power minus 7 ln of dm divided by ds Henry per meter, right? So we know, so we will have different configurations like a single circuit, three-phase single circuit, three-phase double circuit, bundled conductor. So all those things, the only change is uh, we have to find dm and ds in a different way. Likewise, we have to calculate capacitance of the transmission line also, right? So before going to deriving the formula for capacitance, I would like to say, so what are the different things which will capacitance will do. So we know what is mean by capacitor. So what is mean by capacitor? So when any two conductors will be separated by any insulating medium, so we call it as it will be act as a capacitor. So if we consider our transmission line, so there will be, I'm considering a three-phase transmission line. So between two conductors there will be an air. So your air will be act as dielectric medium, and we will say the capacitance will be existing between the conductors. So between two conductors, so we will assume air will as an dielectric medium. So there is an existence of capacitance between the two conductors. So as we said earlier, so capacitance will be throughout the length of the line. So it is not confined at only one place. It is throughout the length it will be presenting. So capacitance that will existing throughout the length of the line. So that we call it as how we will say uniformly distributed line. So uniformly distributed, like inductance, resistance, and all those things. So capacitance will be uniformly distributed along your transmission line. Right. So if we apply an voltage, say I'm between two conductor line, so between two conductors line, so capacitance will be existing. So if we apply the voltage across this, so what will happen? So current will be drawn by your capacitance. So this current we call it as charging current. So if we apply the voltage, so current will be drawn by the capacitance. So that current we call it as charging current. So usually, so charging current because of capacitance will be an leading one. So this current will be a leading current. So normally what we are having, so in the loads in the transmission line, so we will say most of the current will be a lagging one. So this capacitance will draw a leading current. So capacitance will draw leading current. Right. So what will be the advantage of this? leading current. So before going to that, so this current IC, what we are seeing, so IC, so that we call it as, the formula for IC is 2 pi f C into V. So this charging current, so the charging current depends upon three factors. One will be the voltage, another one will be the frequency, and another third one will be the capacitance. This charging current, so that will be independent of the load. So charging current, it will be independent of your loading condition. So this charging current depends only on three factors, that is frequency, capacitance, and voltage. Right. So what will happen if the capacitance, so I am considering capacitance of a overhead transmission line is high. What will happen because of this? So what will happen because of this? Capacitance of the overhead transmission line is high. So if the capacitance is high, what will happen? So the charging current drawn by your transmission line will be high. So what will happen? So this charging current will equalizes or cancels the our load current, which will be actually a lagging current one, right? So this cancels your load current, or it will compensate this load current. So because of this cancellation, so the resultant current, so the resultant current flowing in the transmission line will be gets reduces. So because this capacitive current is leading, inductive current is lagging. So both the will cancels each other. So the total resultant current will be very much less. So if the resultant current flowing in the transmission line is reduced, what will happen? If current reduces in the transmission line, so the losses, so I squared R loss will gets reduces, right? Then if the losses reduces, the efficiency will gets increases. This is one, first one. Second one, because of the current cancels each other, so the voltage drop in the transmission line will gets reduces. So if the voltage drop will reduces, that means voltage regulation will be improved. This is one. Second. Third advantage is, so if we are having high capacitance, if we are having high capacitance, so what will happen? So because of high capacitance, the load capacity will be increased. So load capacity will be increased. This is one, first one. So because of high capacitance, it will increases the load capacity. Second one will be, it improves the power factor. Right? So once again, I repeat from the starting. So we will say capacitance. So what is meant by capacitance? When two conductors are separated by an insulating medium, so we call it as either it is a condenser or capacitor. So if we consider an overhead transmission line, so air will be acting as dielectric medium. So there is an existence of capacitance in the transmission line. So this capacitance that will be uniformly distributed along the line, and just assume this circuit. So if we apply the voltage across the transmission line, so there is an existence of capacitance between your transmission line. So that leads to drawing and leading current. So that leading current we call it as charging current. So this charging current has several advantages. So this charging current formula will be 2 pi f CV. So charging current depends upon frequency, capacitance and voltage, and it will be independent of the load, right? If the capacitance is high, what will happen? So if the capacitance in the overhead transmission line is high, so the line will draw more charging current. So because of this charging current, so that will equalizes or cancels the current drawn by our load. So because of that, so the resultant current will reduces, which in turn reduces the losses, which means the efficiency will be improved. Then second one, because of this capacitance, the voltage drop in the line will be reduced. That means we will have improvement in voltage regulation. If we are having high capacitance, so the advantage in transmission line is the loading capacity will be improved and the power factor will be improved. So now we are going to derive the equation for current, capacitance. So how we have derived the value for inductance. Likewise, we have to derive the value for capacitance. So before going to that, so first we will see what is meant by electric potential. So we know the definition for electric potential. So electric potential at a point due to its charge is the work done in bringing the positive unity charge from infinity to the point, right? So we will say that is an electric potential, right? So bringing an charge which will be from infinity to that particular point, that we call it as electric potential. So for why I am saying electric potential is that will be major thing if we consider for capacitance. So I will consider a conductor which will be of radius r, and the conductor is a conductor, and the charge in the conductor is QA. So I am considering charge in the conductor is QA, and I am considering a point from the center. So it will be P. So the distance between that point P is X. So we do not know that the distance. So I am considering this. So first we are going to find out potential of an charged single conductor. So first we are going to find out potential at a charged single conductor. So first we will see potential of a charged single conductor. So for this I have considered a conductor A which will be of radius is r meters. So this conductor A that will operate at an potential VA that consists of a charge QA per meter that will be existing in the conductor. So we have to find the electric field intensity. So we have to find electric field intensity E at a distance x meter from the center of the conductor. So we know the formula. So E will be equal to QA divided by 2 pi x epsilon naught volts per meter. So we know QA, it is charge per meter length. So epsilon will be the permittivity of the free space. So that is the potential of our charged conductor. Suppose from this electric field intensity, so if we want to find the potential or electric potential is VA, so VA that will be equal to integration of the radius r to the distance infinity. So QA divided by 2 pi epsilon naught x dx. So if we integrate this, so you will get QA divided by 2 pi epsilon naught. So integration of r to infinity dx by x. So this is the potential difference between conductor A and infinity, that is at the infinity. Suppose if we are having a multiple number of conductors. So here we have seen only one conductor. So if we are having number of conductors, so next we are going to see potential of at a conductor, potential at a conductor in a group of charged conductors. So instead of one conductor, so just I am considering a conductor A, conductor B, conductor C, conductor D, E, F. So A, B, C, D. So I am having multiple conductors with their respective charges. So I am considering the distance between conductor A to B will be D1 and A to C will be D2, and the remaining things remains same. So I am having conductor's radius R. Right. So I am considering the conductor A. So first, so I am considering potential of conductor A. Potential of conductor A. So due to its own charge, that is due to QA, due to own charge. So potential at conductor A, so due to charge QA. So QA, so from we have already find out. So infinite integration of R to infinity. So QA divided by 2 pi x epsilon naught dx. Right. So next is potential at conductor A. So due to charge QB. So we are considering number of conductors. So now we are going to find potential at A. Potential at A due to charge QB. So integration of So instead of R, so D1 will be the distance between conductor A to B. So there is only one change. So QB divided by 2 pi x epsilon naught dx. So if I consider QC, so potential at A due to QC. So I have to give the distance between conductor A to C. So I am considering A to C distance is D2. So instead of D1, I am having D2. So charge will be QC divided by 2 pi epsilon x epsilon naught dx. Right? So if I want to find overall potential difference of conductor VA, so I have to add all these things. That is integration of R to infinity QA divided by 2 pi x epsilon naught dx plus integration of d1 to infinity QB divided by 2 pi x epsilon naught dx plus integration of d2 to infinity QC divided by 2 pi x epsilon naught dx. Right? So we had to add. So if I am consider another 3, 4, 5, 6, all those things. So we have to add this together. Right? So we have to solve this. So for finding VA, so we have to solve this. So I am taking 1 by 2 pi epsilon naught outside. So you will get, so QA will be there. So integration of 1 by x. So that will be log x. So if you substitute, you will get, so logarithm of infinity log e infinity minus log e r plus similarly for QB log infinity minus logarithm of d1 plus QC, the same thing will be there. Here you will get the difference will be logarithm of d2. So once if we find this thing, so we have to take logarithmic thing outside, or we can write, so minus logarithm of log e, or we can write it as log of r power minus 1. So this we can write it log b of 1 by, right? So if we replace minus log e divided by that will be 1 by r. So 1 by 2 pi sigma naught q a logarithm e of 1 by R plus QB logarithmic E of 1 by D1 plus QC logarithmic E of 1 by D2. So this will goes if we increase the conductor. So we will have logarithmic infinity, right? So plus log E infinity. If I consider, I'm taking outside, so you will get QA, QB, and QC. So this, if we are assuming a balanced condition, so all the charges remains same. So the summation of these values will be equal to 0. So we are neglecting this term. So we will have only the term balances. So VA, that will be equal to 1 by 2 pi sigma naught, so QA into 1 by R plus QB into logarithmic E of 1 by D1 plus QC into logarithmic E of 1 by D2. Right? So this is the potential difference of conductor A 2 to the infinity pair. So we have considered a conductor, a single conductor. We have formed the potential of charged single conductor, and we have formed, suppose if the potential at a conductor if we are having n number of conductors. So what we have determined is, we have determined the potential difference of conductor A. So we are here to determine the capacitance. So we have to derive the capacitance. So capacitance of a single phase two wire line. So first we are going to see, so capacitance of a single phase two wire line. Right. So for this, I am considering a conductor A, which will be of radius R. So conductor A, so it consists of charge Q. So I am having another conductor because it is a single phase line. So we are having two conductors. So we are having two conductors. So I am having conductor B with radius R, same thing. And these two conductors will be separated by a distance D. So the charge of conductor A is plus Q and charge of conductor B is minus Q. So as we said, so in phase wire, so the current will be flowing. In neutral wire, it will be returning. So I am assuming charge in conductor A is positive and charge in conductor B is negative. So we have to find the potential difference of conductor A. So VA we have to find. So we can have two options. One will be through self charge, another one will be through another conductor. So integral r to infinity. So charge will be plus q divided by 2 pi x sigma naught dx. This is first one. Second one will be integral of distance d to infinity, and the charge is minus q. So minus q divided by 2 pi x sigma naught dx. So this is for conductor A. If I want to find for conductor B, so conductor B, I am considering internal r to infinity minus q divided by 2 pi x sigma naught dx plus integral, the distance is d and infinity, so charge will be q divided by 2 pi x sigma naught dx. So both equations will be same. So VA and VB will be same. So we can write same thing. If we derive, what we will get? So I am deriving for VA. So VA I am deriving. So I am having the charge. So Q I am taking out Q divided by 2 pi sigma naught outside. So I will get if I integrate, so I will get logarithmic of infinity by r plus minus logarithmic of infinity by d. Right? So this I can write. So infinity that will be, I am neglecting. So I will get q divided by 2 pi sigma naught. So we are having minus. So log of logarithmic of, so d divided by r. So if we derive for VB, so we can have the same equation, but the instead of plus Q, so we are getting minus Q. So both the potential will be same. VA and VB will be same. Only thing is plus and minus will be there. So plus Q and minus Q indicates the charge at that particular conductor. So we want to find uh, capacitance. So instead, so if I want to voltage of VAB, I can write 2 into VA or 2 into VB, because both the equations looks like same. So if I add together, it will be double times of the value. So VAB value is, so 2Q divided by 2 pi sigma naught logarithm of d divided by r. So capacitance. So the formula for capacitance. So the formula for capacitance will be charge q divided by a voltage VAB. Right? So we know VAB we have found out. So q divided by, so divided by 2 pi sigma naught logarithm of d by r. So this q and q will cancel each other. This pi and sigma naught will go upside. So pi sigma naught divided by logarithm of d by r. Farad per. So the formula for capacitance is So pi into sigma naught logarithm of d by r. Right? So inductance we will write, so 2 into 10 power minus 7 ln of d by r, right? So here it is logarithm of ln of again d by r. So the formula for it is a capacitance between conductor A to B. So if it is between two conductors, so the formula is pi sigma naught divided by ln of d by r farad per meter. Suppose if I want to find so capacitance between neutral, so if I want the capacitance between neutral, so I can draw a diagram. So I'm having conductor A and I'm having conductor B. So between this I'm having capacitance. So we will say it is CAB. So what we have find out. So pi sigma naught divided by ln of d by r farad per meter. Suppose if I want to find capacitance between neutral. So I'm having two conductors. I'm having neutral point. So CAN or CAN will be equal to 2 times of CAB. CBN will be equal to 2 times of CAB. So if I want to find capacitance with respect to neutral, so what it implies, so the capacitance to neutral with the conductor to neutral, so Cn implies double times of conductor A to B are between two conductors. So if I want to find capacitance of a conductor with respect to neutral, so we have to multiply by 2. So if Cn will be 2 pi sigma naught divided by ln of d by r. So if I want the capacitance between two conductors, so it is CAB. So pi sigma naught ln of d by r farad per meter. If I want between neutral or capacitance to neutral, it will be double times the value of capacitance, right? So same formula we are going to do it for capacitance, or we can say general formula we can write CAB will be equal to 2 pi sigma naught divided by ln of d by r. So I will write general formula dm by ds, unit will be farad per meter. So this dm and ds, it will be similar to what or how we have calculated for inductance, right? So this dm and ds based upon the conductor configuration, it will vary. Right? So based upon the conductor configuration, it will vary. So we have to, for each configuration, we have to find dm and ds as like inductance. So the only difference in finding a dm and ds, mutual will be same for capacitance as well as inductance. So only one change in the ds. What is mean by ds? So ds, so we consider it as self-inductance, right? So in inductance, we will consider self-inductance will be equal to R dash. But in capacitance, so instead of R dash, so we have to substitute only R. So that is the difference, right? So in inductance problem, for calculating ds, so we have substituted or we have find out R dash. So in capacitance, we are not using R dash, so we are going to use only R. So in simple words, if we replace R dash by R in inductance calculation, so that will be equal to capacitance calculation. So that is the difference between a calculation of ds in inductance as well as capacitance, right? So another thing will be bending. So three-phase symmetrical line, capacitance of three-phase overhead transmission line. So we will solve one problem pertaining to this. Then you will understand the capacitance problem. So I will put one small problem here. Then you will understand the how to find out capacitance. So I'm considering first problem. So two parallel conductors having distance d will be 3 meters and the radius of each conductor will be 1 centimeter. So the distance between two conductors is 3 meters. Radius of each conductor is 1 meter. So calculate capacitance per kilometer. So calculate capacitance per kilometer. So epsilon naught. So just assume that 8.854 into 10 power minus 12 farad per meter. So what is the formula? So capacitance of the transmission line CAB, that will be pi sigma naught divided by logarithmic E of, or we can say calculator, we will use ln. So ln of d by r farad per meter. So we know all the values. So d value we know, r value we know, epsilon value we know. So only thing is it will be in meter, it will be in centimeter. So convert that into any one quantity, either meter or centimeter. So I will convert that into centimeter. So d I am considering 300 centimeter, radius I am considering 1 centimeter. So just tell me the capacitance value. So whatever you get in the calculator, it will be in terms of farad per meter. So I need in terms of per kilometer. So just calculate and tell me the answer for this capacitance. So problem 1, I am considering the distance between the conductor is 3 meter, radius of the conductor is 1 centimeter. So we have to find out capacitance per kilometer. So given the epsilon naught value will be 8.854 into 10 power minus 12. So you just tell me the answer for that. So with this, I will stop. So do you have any doubts, or I will stop with this? Right. So that's all from my side. So thank